Problem 40. Write the following logarithmic expression as a single logarithm whose coefficient is 1. 1 over 2 logarithm of x with respect to base 2 plus 2 times logarithm of x plus 2 with respect to base 2 minus 1 over 3 logarithm of z with respect to base 2. Now this question is using the logarithmic properties, but in the opposite direction as in the previous question, problem 39. And I'm not going to go over the properties of logarithm. You can watch that video, but these are the rules we'll be using, except this time we're going to go in the opposite direction. So what I like to do first is well, that's kind of not that optional. I'll be using the rule multiple outside is equivalent to power inside. Using that rule multiple times, so logarithm of m with respect to base m to n with respect to base b equals to n times logarithm of m with respect to base b, but we'll be using this in this direction. So 1 over 2 multiple 1 over 2 outside becomes the power 1 over 2 inside. Multiple 2 outside for the second term becomes the power 2 inside, but it is the power of the whole inside, right? So you have to be a little careful with the parentheses. And that minus, I'm going to bring it with the minus. So logarithm of z to the power negative 1 over 3. So that minus, I break it as plus minus 1 over 3 times logarithm of z with respect to base 2. I'll write it like that, and then I take this number. And then I can put these guys together. So multiplication outside is the same thing as, sorry, multiplication inside. Ooh. There is no rule with multiplication outside. Multiplication inside is the same thing as addition outside. Rule. So logarithm of product is the same thing as sum of logarithms, but we'll be using this rule in the direction where we condense, right? We have more log terms, we want to end up with fewer. So logarithm, one big logarithm, x to 1/2 times y plus 2 to the second power, z to the power 1 over 3, all based 2. And then we can do a little bit of cleaning inside, rewriting things. So x to 1/2 is the same thing as square root of x. And there is nothing I can do with y plus 2 squared. And I forgot that minus here. And z to negative 1 over 3 is the same thing as z 1 over z to 1 over 3. So that minus in the exponent corresponds to 1 over. Additive inverse in the exponent is multiplicative inverse for the total. And then I can rewrite it as the third root. By the way, I mean, this answer is also acceptable. You can leave the rational exponents, but that wouldn't be a big deal. They both mean the same thing. Let me quickly go to the answers and see if this was correct. And it is not correct. The answer is wrong. On the answer key, I'll fix it. This is correct answer.